Hello everyone, this is Pravesh Malviya. So in the previous lecture we discussed about the working principle of DC generator, and in this video we'll be discussing about the classification of the DC generator. So a DC generator can be classified in several ways. It can be classified based on the connection between its armature and the field winding. So let's start with the classification. So a common classification for the DC generator can be, it can be either permanent magnet type or it can be either electromagnet type. Electromagnet DC generator can be classified in separately excited and self-excited. So we can see here that the field winding here in the separately excited generator is excited by a different voltage source, a separate voltage source. The self-excited DC generator can be classified as series wound, shunt wound and compound wound. So we can see that in series wound the armature and the field circuit is in series combination. In shunt they are parallel to each other. And then the compound wound DC generator can be furthermore classified in long shunt compound wound and short shunt compound wound. So in this lecture we will be discussing all these classification one by one. So we start with permanent magnet DC generator. Here we can see that the field is not the electromagnet here. The field is the permanent magnets. So as the name says that this is a permanent magnet field type of DC generator. The problem with this generator is that we cannot control the flux in the field circuit. It is constant always. If it is electromagnet type field, then we can control the flux by increasing or decreasing the current. So this is the permanent magnet type DC generator. It is employed where we need a constant speed, where we do not need to change the speed for any specified load. So I think we must have seen the permanent magnet DC motor or DC generators in our household devices such as the tape recorder, CD player, etc. So now coming to the second one, that is the separately excited DC generator. So separately excited DC generator is here. We can see its circuit. In this circuit we can clearly see that the field of this generator is excited by a separate source. Separate means there is no connection in the field circuit and in this armature circuit. So both of them are separate. So we can say that this is a separately excited DC generator. So if we have to increase or decrease the terminal voltage for this generator, we can vary it by increasing or decreasing the field current flowing in that separate circuit. So for this circuit, the armature current, this is the armature current IA, is equal to the load current. This is the load current which is flowing in the load. Both are equal to each other. And the voltage across the load can be given as V is equal to IR, where I is this load current or the armature current and R is the armature resistance. So this is separately excited DC generator. Now coming to the next one, that is the self-excited DC generator, and we will be discussing about the series wound self-excited DC generator. So the circuit says clearly that the armature circuit and the field circuit, both of them are connected together in series connection. So we can clearly see here that Eg is the generated EMF, V is the load voltage, and as everything is connected in series, so the armature current is the series winding current and it is the load current. So we can see clearly with this circuit that the armature current and the winding current and the load current all are equal to each other, all are same. And for this, the generated voltage, the load voltage V can be given as Eg minus IaRa. This Eg is the generated EMF and this I is the armature current and Ra is the armature resistance. Now coming to the next one, that is the shunt wound. So this is the shunt wound type of self-excited DC generator we are talking about. So we can see that the armature circuit and the field circuit are connected parallel to each other. So this is shunt wound type of self-excited DC generator, and if we look at this circuit, we see that in this entire circuit the source is this armature circuit. This armature circuit will feed the load as well as the field circuit. So the armature current gets divided into the load current and the field current. So we can say, according to KCL, that the armature current is equal to the field current plus load current. This is the armature current Ia, this is the field current, and this is the load current. So we can say that the ISH, the shunt field current, is equal to V upon RSH, where V is the load terminal voltage and RSH is the resistance of the field winding, shunt winding. And according to this, mathematically we can say that the terminal voltage is equal to the generated EMF minus the drop, and the drop is IaRa. Now coming to the next one, that is the compound wound. Now till now we have seen the series wound and shunt wound in self-excited type. In series wound we have seen that the armature circuit was connected in series with the field circuit, and in shunt we have seen that the armature circuit was connected parallel to the field circuit. But when we talk about the compound wound, we find both these connections here. So series and shunt, both type of generators have their own issues, have their own technical problems with them. In series wound generators, the output voltage is directly proportional to the load current. In shunt wound generator, the output voltage is inversely proportional to the load current. So the voltage, the terminal voltage, which is very much important parameter for the entire system, is dependent on the load current directly or inversely proportional in series and shunt wound. So what is the solution of this problem? Combination of these generators can overcome this problem. So for this we have introduced the compound wound. So the compound wound generators have both the series field winding as well as the shunt field winding. One winding is placed in series with the armature and another winding is placed in parallel with the armature. So depending upon these two type, it can be categorized in short shunt compound wound and long shunt compound wound. So we start with the short shunt compound wound DC generator. So this is a type of self-excited DC generator. So here we can see that the shunt winding, the field circuit, the shunt winding is connected in parallel with the armature, and this parallel combination is connected in series with a series field. So in short shunt compound wound generator, we can see that a parallel combination of armature and shunt winding is connected in series with a series field. So this is the load current IL, this is the series field current ISC, this is ISH is the shunt field current, and IA is the armature current. EG is the generated EMF, RA is the armature resistance, and V is the load voltage. So according to this circuit, ISC is IL, the load current and the series field current are same, and the shunt field current can be given as V plus ISC RSC upon RSH according to Ohm's law. And according to KCL, we can say that IA is equal to ISH plus IL, where it is. So this is the node, we can say. At this node, if we apply KCL, so we can say that ISH plus IL is equal to IA. And the load voltage, the terminal voltage can be given as EG minus IARA minus ISC RAC. So both of these are the drops. So this was the short shunt compound. Now coming to the long shunt compound wound. So there is a difference between short shunt and long shunt compound, and there is similarity also. Both of the compound wound types have series as well as the shunt field. So there are two field windings are together, but there is a connection between their combination. So we discussed short shunt compound wound. In that we saw that the parallel combination is connected in series with a field. Now here we can see that a series combination of armature and field is connected in parallel with another field. Okay, once again, for better understanding, I go to previous slide. Here we can see that a parallel combination of armature and field is connected in series with a field, and here a series combination is connected in parallel with another field. So here we can see that EG is the generated EMF, RA is the armature resistance, IA is the armature current, and that is the same current which is the series current, and at this node it is divided into the load current and the shunt field current. So mathematically we can say that the shunt field current according to Ohm's law can be given as V upon RSH, where V is the terminal voltage and RSH is the shunt field resistance. And at this node, if we apply KCL, we can say that ISC, the series field current or armature current, can be given as IL plus ISH. And the terminal voltage can now be given as the generated EMF minus drops. So these are the drops here. So this is all about the long shunt compound wound. Now let's discuss a fact about these compound wound generator. So these two windings we discussed, that there are two windings, series and shunt windings are there. So on a single core, on a single pole, there will be two windings. One will be the series and another one will be shunt. So now these windings, when current flow through these windings, flux is set up in entire core. But the flux has its a definite direction, and that depends upon the direction of current flowing in the winding, or the way of winding, the way of conductor has been wound over this core. So whatever may be the reason, when both the windings support each other, it means in a compound wound generator, the shunt field is actually stronger than the series field. Why it is so? Because the shunt field is having many number of turns, so it is generally stronger than the series field, because the series field have few number of turns of thick wire. When the series field assists the shunt field, it means the flux setup in the core, entire core, is in same direction. So when the series field assists the shunt field, generator is said to be cumulatively compound. So here we can see that this is the cumulatively compound, and when the series field oppose the shunt field, the generator is said to be differential compound. So when both the winding series and shunt are working together, then we can say that it is cumulatively compound. But when they are acting opposite to each other, we can say that it is differentially compound wound. So this is all about the classification of DC generator. So I hope you enjoyed this video, and in case of any doubt, you can contact me anytime. Thanks for watching.